Okay, today is our first lab. So one of the things that makes this class different from regular is that we do labs. And these labs are an attempt to connect what you are learning to the real world in a better way so that you can see, oh, this math that we just did, now I'm using it in a little tiny project. These projects are like typically a question that's kind of open-ended, and that will kind of annoy some of you. Like, tell me exactly what to do and I'll do it. Okay, well, but in the real world, that's not necessarily what happens. In the real world, let's say that you're hired by Apple to figure out a new kind of charging system that doesn't exist. They just say, figure out a new kind of charging system that doesn't exist. We want an advantage over our competition. And then you have to figure it out. Like, it's open-ended. And yeah, granted, you get a long time to do it, and you get paid a lot of money to do it for Apple, but here, you have a not too long of a time to do it, but we kind of give you some guidelines. But there's a lot of freedom, and that's on purpose. Okay, so you just have to do what it says, but there's a lot of different ways to meet those requirements, and therefore your roller coasters will look completely different than a kid next to you's roller coaster. We don't want you to just make all the same exact thing, okay? All right, so what are the requirements in this particular lab? Let's read through the purpose. This, first of all, it really should say that we are going to be trying to make a roller coaster, okay? And with line AB, that's this little piece, that's part of a piecewise function. Parabola BC, obviously they want that to be a parabola. It kind of looks like a half circle, but it's not. It's a parabola. And last but not least, the square root function, that's from here to here. That whole thing is a square root function. Those three things make up your roller coaster. Can you just use any line you want? No, there are some requirements. At point A, it needs to be 30 meters high. They call it point A. Couldn't they have called it the y-intercept? The y-intercept of line AB has got to be 30. Now, when you all have different equations, what do they all have to have in common? They all have to have a y-intercept. 30. Does it say exactly what the slope needs to be? Nope. Doesn't say that. All right. Next, it says point B and C are 10 meters high. Okay, so basically the beginning and the end of your little parabola section, this little part's a parabola, the beginning and the end of it need to be 10. Does it say how deep it needs to go? Nope. Could you have a really mellow bottom section like this? Yep. Could you really have a really deep one that even goes underground? Doesn't say you can't. Okay, so you have lots of options, but what is the requirement? It has to be at 10 meters. That height of 10 is where the parabola starts and ends. Okay, last but not least, point D is 25 meters above ground level. Okay, this D right here really should be up here. Would you guys all please move it to there? That D is supposed to be the ending point of your little square root function. How do you get it to stop there? Otherwise, wouldn't it just go forever? Yeah, square roots do go forever. They start in one spot, and they normally go forever. How are you going to get it to stop? You use a domain. You say, this could be, I'm just going to totally make one up here. Would you agree it is a square root function that has been moved to the right, some unknown amount? Doesn't say how far it needs to move to the right. You have to figure that out. Depends on your equation, what you want to do. Let's say you want to move it to 100 to the right. Then I'd say it would be x minus 100. And then I definitely want it to go up 10 feet though, right? Because I want it to hit here. So then I got to say plus 10. So I'm going to slide this over and say plus 10 on the outside of the square root. And then I want it to stop there, which, what is that? Oh, that's the spot where the y is 25. See, y is 25 over there? How do I get this thing to stop? Otherwise, it'll go forever. I say the domain is that x needs to be less than or equal to, well, I better figure out what x is right there. How am I supposed to know what x is right there? Well, you know the y is 25. Put a 25 here. You'd be able to figure out what x was. All right. So then I'd solve that. Add, let's say it ends up being I don't know, I'm just going to ballpark how high does that look, or no, how far to the right does that look? Well, if I said that's 100, maybe that's like 200 or something like that. That'll stop my parabola from going forever, or my square root from going forever. All right, so there's a quick talk through of this lab. And you might be like, well, what do I do to start? Well, let's just back up and look at the big picture. You're supposed to write an equation for a straight line that starts at 30. You think you could do that? I hope so. Do you agree it's got a negative slope? All right. And then if you just write an equation that goes forever, that'll be a problem. We need it to stop. Where do we need it to stop? We need it to stop right there so that it doesn't go past that spot. Well, then how are you going to do that? That's your job. You figure that out. I would encourage you to use a domain and just say x has to be less than, well, you figure out what that number is. And that'll be your first equation. Everybody just write me a quick equation that would qualify for that line that goes from A to B. Write what you think would be an answer that you think might qualify. And then all you got to do is back up and say to yourself, does mine have a y-intercept of 30 and a negative slope? And if it does, it's fine as long as you didn't let it run forever. See, let's say George has this. It's got a negative slope. It's got a y-intercept of 30, but he just says that. He loses points because his is not a piecewise function. His would keep on going forever, and I want it to stop there. So he should have really said something about x needs to stay between 0 and can't go past, well, I don't know what he wants to pick for that. Let's say he picks 50 for that. There's the first part of my piecewise function. Now, you can't use mine because I made that one. You can do something similar though. And it looks pretty steep, so maybe it needs to be steeper than 2x. I don't know. And I just slapped a 50 in there. You have to decide how far over those are. It doesn't say. All right. Now, some kids have had fun with using Desmos to make these graphs. Okay? Because you can do it on Desmos as opposed to your graphing calculator. And I don't know, you get different colors in there and it just looks nice, and a lot of people like using that kind of technology. I don't want to say you have to use your graphing calculator, but Desmos is actually easier to set domains on too. So the graphing calculator, how do you tell it to graph something but only from here to here? All right, let's look at Desmos for a minute. So this part, unfortunately, I can't record for you. So we're just going to go to desmos.com and see what we can learn about using Desmos for the graphing. And pause for a second while I do that. Okay, so I gave some hints on how you would use Desmos. The biggest hint I want to give here, in case you're at home and wondering how this works on Desmos, I'd go to desmos.com and then I'd hit the graphing thing. And I would say, let's say I wanted to say y equals negative 2x plus 30. That's a good way to start, by the way, for this. But I want to limit its domain. You look for these symbols and you say 0 is less than x is less than, let's say, 10. And then it'll only show you that part of the graph. You put that in right after this, and that'll limit your graph to just the part you want. Okay. Last thing I want to call your attention to is it says that the square root function, this last little part of the piecewise function, should be 25 meters above the ground level. That means when this coaster comes to a stop, they want it to be at 25 meters up and with nearly 0 slope. That means they don't want your roller coaster to end looking like that. Because think about it in real world. Do you want your roller coaster sitting like that at the end? No, because if something goes wrong, you're going to roll backwards and that's not good. Okay? So they want your roller coaster to end kind of like that. Nice and flat. Very low slope at the end. So this is good. This would be bad. Because of how a roller coaster works, you want it to be on almost level ground. Okay? All right. Now, how are you going to get graded on all this? I want you to go to the next slide that says Format for All Labs. In a moment, I'm going to ask you to turn your iPads my way so I can see how many of you are with me. Turn your iPads my way. Have you found Format for All Labs? If you're not there, get there now. Almost everybody's with me. Thank you. Thank you. This has your points. You're going to get 2 points for the purpose. All right. Now, there's some like side rules here. Number one, the purpose cannot just be you verbatim copying what they said. You have to say it in your own words. What are you doing here? Well, you're making a roller coaster. And you're making it with a piecewise function. That would be a pretty good purpose. That's it. I'm not looking for something to break scientific ground here. I just want you to explain what you're generally doing. And you have to do it in your own words. If you copy the words from the original slide, you won't get credit for it. You have to say it in your own words. Okay, next, there has to be a sketch. Well, this is all about building a sketch. But just make sure every lab has a sketch. This one just happens to be a super detailed sketch, is the whole point. But what are the things that they ask for? In this case, us in action, ideally, well, we're not actually doing something in the classroom this time. A lot of the labs are like us bouncing a ball or whatever. And if you include a picture of that, that does adds a lot to your lab. It really gives you the feeling that as you're reading it, that you're seeing the kid doing the lab. But in this case, a picture of you on your iPad is probably not like worth anything. One last thing to note here. Labeled graphs. If at the end you didn't have an X and a Y label and you didn't have numbers on your axes, you would not get points. So that's how I grade the sketches usually. Did they label it and they put numbers on it that were appropriate? Okay, next. There's 4 points for procedure, and feel free to write this down. Describe in words what you did. This is saying, big picture, you stepping back and like talking to me via a few sentences. Here's what I did. Well, I set up a piecewise function. So first I took and made the straight line part, and I made sure that it had it started at 30 meters high. Next, I found this other function, and I made sure that So this is where you say what you did. I don't need 6 paragraphs. Okay, I need a good paragraph that describes what you did in this lab. Not a restatement of just like generally I did this. Specifically, what did you do? All right, and then last is, well, no, not quite last. The next is calculations, and this is where you show work like equations. Remember, the whole goal of this was to create a piecewise function. This is where you would actually write down, here's the piecewise function that I made. Okay, and if sometimes you need to solve equations, in this case, there's not much equations to solve. A lot of times, real world ones, you bounce a ball, and you get data, and then you solve an equation. This is where you'd actually show your work of solving the equation. The other parts where you say what you're doing in words, this is where you actually show your work. And then last part is always a couple points or 4 points actually, for conclusion and reflection. This is where you need to restate. My conclusion is I have got this answer to the question. You've got to answer the original question. The original question was, what would be the equation for a piecewise equation that would do this? And you got to say, well, here is my piecewise equation. That's where you actually put your answer. And then reflection. Notice this says list 3 math-centered things you learned. Now, I want you to be specific. It can't just be, I used math in the real world. Nope, I will train people to watch for that when they're grading these and not give you points for that. You're going to get points for things like, actually it was interesting to learn how to use Desmos to set domains. That's something you probably, maybe you've forgotten how to do, and now you've seen how to do it, and you learned something, and it's specific, and it's about math. Okay? Another one would be, I also will give you credit for those 3 math-centered things you learned for a way to improve this lab for next year. Because I am open to ideas. And it shouldn't just be make it more complicated. you know, like, because we can always make it more complicated. But maybe it could be, you know, like these directions need to be better in this area, or, you know, anytime you're like having trouble thinking of a math-centered thing that's specific, if you want to give me I think this lab would be better if we did blah, 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 blah. Cool, I want to hear about that. So that can be one of your 3 things you learned, is that, Mr. Server, your lab sucked and it should be better because of this. Okay, and you don't have to say that first part, but it'd be good if you gave me ideas on how to make the lab better. Okay, so then that gives you a total of 20 points, and these are usually going to count in the homework category. It's very rare for me to ever not grade one. There will be probably 16 labs between now and the end of the year, and I'm pretty much going to grade every single one of them. Not everyone. Every now and then I will say, oh, this one we're not grading. But almost always we grade them, and we put them in the grade book, and therefore they count as a decent portion of your grade, because the formative part has got a lot of labs in it. Okay, so do these. They were twice as much as a homework assignment. Homework assignments are 10, these are 20. Okay? Okay, last thought. What does it actually look like? Well, don't answer your questions on here. This is just a format page, which is telling you how much each thing is worth. So what do you actually do? Some pages built in. Oh, and some frequently asked questions. Kids ask me these a lot, and I've got the answers to them. So read those quick. Does my piecewise function have to have a domain? Yeah, definitely. Because if it doesn't have a domain, it's going to not be a piecewise function. It won't really be a function because it won't pass a vertical line test. All right, anyway. And you just have something like this. See how it says Mad Mouse Lab at the top? And you have your name, and then you start from there. And what I would do is put purpose. And it's okay for you to write it out, because I know you're on an iPad and you don't have a keyboard. If you write, though, you need to write it legibly so somebody can read it. Okay, because if we can't read it, as in if this is graded by another student in class, like a lot of our assignments are, I'm going to tell the kid, if you can't read it, mark it wrong. Okay, so read it, or write it so they can read it. My handwriting is not awesome, so I should just slow down a beat when I'm writing this and make sure, because if I slow down, I can write better. And bigger also is easier to read. Totally okay with that. All right. If you want to make it smaller, you can shrink it like that. See? Write big and shrink it down. All right. And if I were you, I'd label each section, because when the person's trying to find your sketch, and if you haven't labeled a sketch anywhere and they're like looking and I don't see it, I'm going to say mark off the 4 points, because they haven't labeled a sketch for you. So you should have each section. Purpose is the first one. Sketch is the next one. And you won't really have your sketch until you're all done with this thing, so you kind of leave that one blank until you're done for later. Make sure your sketch is labeled, though. I warned you. Other common mistakes? Titles are labels. If you don't have a title for your sketch, you're going to lose points. Another one, a lot of people just they forget to make the 3 reflections at the end. It's conclusion and reflections. A lot of people think that their conclusion was up higher. If underneath the conclusion section, you need to state your conclusion. If your conclusion isn't in the conclusion, and it's up higher in the purpose section or something, you're not going to get the points for the last part, which is called conclusion and reflection. So your conclusion and reflection, surprisingly enough, needs a conclusion and 3 reflections. All right. I think you have the idea how these labs are supposed to work. There's a lot of open-endedness. Yours might look different than a friend's. Just make sure that you are doing what the lab asked, and there's oftentimes more than one way to do that. Now, can kids work together? Yes, kids can work together. Can a kid just copy another kid's lab? No, that's cheating. There's a big difference. If you and a friend want to work together on it, that's fine. But that means like sharing back and forth and like helping each other and working together. That's okay. But you also cannot turn the exact same sheet. Hey, you're better at writing, George, so I'll just have you write the whole thing while I sit here and advise. No, that's not you guys working together. That's you leeching off of George. Okay. So you got to do your own. But if you want to work together with somebody like, hey, how'd you do this part? Totally okay with that. Or you want to help figure out the square root, and I'll do the other one or whatever. share the work, it's okay. But you have to make your own, in your own handwriting, on your own iPad. And then when it's all done, we'll drop it in the Dropbox. So, since this is your only assignment for tonight, I encourage you to just do it, get her done right now. But to give you the idea how these normally go, this is not due till Friday. Okay? But since I didn't give you anything else tonight, a lot of times this just gets thrown in on a normal day where you don't have a whole night to work on it. This is just like part of a 10 minutes, 15 minutes intro on a lab. The reason it took so long today is explaining how the labs work. But on a normal day, we teach a normal lesson and just have like a little introduction to the lab, and it's due Friday. And then the next day we talk about it a little more, but it's still due Friday. And then you got a few more days to work on it, and it's due Friday. So these usually are like a process. We don't normally have a whole day like this. But for the first one, I thought it would be logical to take a whole day, make sure you totally understood how the labs work, give you a chance to ask questions in class, and it's still not due till Friday. But don't be mean to later you. Later you is going to hate now you if you don't do it and save it up to Thursday night when you'll have probably 10 other things to do. Okay. That's all I have for the video for today. And if you have questions, come on up. And yes, you're going to get your test back in a second here.